Today we're here to show how, with a very small but efficient Dankoff solar pump, very little energy can be used to move water a great distance or under great pressure. This is the Dankoff Solar Slow Pump Surface Pump, model 1322, which is a 48-volt version. This pump comes in 12, 24, and 48-volt varieties, depending on what the consumer needs for their application. Some facts about the Solar Slow Pump. It was one of the world's first commercially available solar water pumps. It was developed in 1983 and has thousands of installed units over its 40-year life. It is produced in a wide variety of sizes, and it is really intended to draw water from a shallow source such as a spring, a cistern, or even a river. When set up correctly, it can push water as high as 560 vertical feet. Though it would be a very low volume, it could essentially run all the time on a battery bank that was solar recharged. That's how we recommend that people use it. Construction and features. It is a rotary vane mechanism made of brass and stainless steel. It is NSF approved for drinking water and can handle seawater and is mostly freeze tolerant. It has a permanent magnet DC brushed motor. This is by design so that the brushes can be replaced. Water must be filtered clean on the input side. To create a nice and even flow, we recommend that people tie the pump to a battery system and use solar panels to charge the batteries throughout the day. You can run a slow pump from the solar panel directly, but it will produce a very varied output. This 1322 weighs about 12 pounds and is about 18 inches long by 6 inches. The Dankoff solar line of pumps is highly efficient and sized in a way that can easily outperform the amount of energy produced by a modern solar panel. One commercial-grade 400-watt solar panel can charge a good-sized battery bank and run this pump for days on end with a single solar panel. This demonstration setup is intended to show the amount of energy used based on the amount of pressure the pump is experiencing. In this instance, pressure means lift. So, as we increase the pressure, what we're really doing is simulating how high the pump is pushing the water. We call that total head. First, we see an open flow situation where we're just moving water across level ground. It doesn't really change elevation. We're pulling water just a few feet below our setup table as if we were pulling out of a shallow well. It is flowing about half a gallon per minute. Throughout a day, you'd move about 1,400 gallons of water with no back pressure. Here we see that we are providing a steady 51.6 volts into the 48-volt motor. That's going to remain unchanged throughout our video. At this flow rate, the pump is drawing about 0.6 amps for what we'll consider to be very minimal head pressure, just 2 psi. This is because we're drawing out of a tank just a couple feet below the table. Based on this initial setup, the pump would run for over 166 hours without recharging the batteries. This is an incredible amount of efficiency for a small package. Now we're going to add a ball valve, which you can see to the right. We're going to increase the pressure on the ball valve, which is going to simulate pushing the water up a hill. We've increased the pressure to 50 psi, or approximately 125 vertical feet of lift. We're drawing around 0.96 amps and flowing about a half gallon per minute with a 100 amp hour lithium battery, which is what we recommend. 100 divided by 0.96 would yield approximately 104 running hours, or 4.3 days without recharging the battery pack. Here we are at 100 psi, or approximately 232 vertical feet of lift. We're drawing around 1.52 amps and flowing just under a half a gallon a minute with a 100 amp hour battery. This would give us approximately 66 running hours, or a little over 2.5 days. Now we're at 150 psi, or approximately 340 vertical feet of lift. We're drawing around 2.2 amps and flowing about 0.4 gallons per minute with a 100 amp hour battery. We would achieve approximately 45 running hours, or just under 2 days of non-recharge time. Finally, here we are at 200 psi, or approximately 464 vertical feet of lift. We're drawing around 3 amps and flowing about 0.25 gallons per minute with a 100 amp hour battery. This setup would yield approximately 33 running hours, or almost a day and a half on only batteries without recharge. As you can see, these figures are incredibly efficient for any pump. The slow pump was designed to run literally all day, every day, for years without stopping. Once its performance falls off, it can be rebuilt and maintained to continue that cycle once again. Dankoff Solar, an investment in your future.